Hi everyone, in this video I will be discussing integrals involving trigonometric functions. So before, when you took up differential calculus, you also talked about finding the derivative of trigonometric functions. So these rules are simply the reverse when you had differential calculus. So if you're familiar with the rules in finding the derivative of trigonometric functions, it will be easy for you to understand the rules for finding the integrals of trigonometric functions. So number one, we have the integral of sine x dx is simply equal to negative cosine x plus c. Second one, the integral of cosine x dx, that is equal to sine x plus c. Third, the integral of secant x dx is simply the natural logarithm of the absolute value of secant x plus tangent x plus c. Fourth one, the integral of tangent x dx is equal to the natural logarithm of the absolute value of secant x plus c. Fifth one, the integral of cosecant x dx is equal to the natural logarithm of the absolute value of cosecant x minus cotangent x plus c. Number 6, the integral of secant squared x dx is equal to tangent x plus c. 7, the integral of secant x tangent x dx is equal to secant x plus c. Number 8, the integral of cosecant squared x is equal to negative cotangent x plus c. And number 9, the integral of cosecant x cotangent x dx is equal to negative cosecant x plus c. For number 8, I forgot to put dx. So for now, you don't need to memorize the formulas or the rules. Just be familiar. Anyway, as we will be applying the rules or the formulas later on, you might be able to memorize these given rules. So let's try some given examples. We have here example number 1. The integral of sine 1/4 x dx. So for this, we can still apply U substitution. So we can let U be equal to 1/4 x. And of course, du over dx, or the derivative of 1/4 x, is simply 1/4 dx. Now, if you would recall from earlier, the integral of sine x dx is equal to, that's negative cosine x plus c. So, let's try to rewrite the given function. So, that's the integral of sine 1/4 x. So, that's our u. Now, since du here is 1/4 dx, we can rewrite this part. We can make that, or write that one as 1/4 dx. Now, since we put 1/4 here, we need to put 4 outside of our radical symbol in order to offset 1/4. So that's equal to 4. Using U substitution, this is now sine U, and this is our du. So going back to the rule, sine U du or sine x dx, that is equal to negative cosine x plus c. So that will become negative 4 cosine u plus c. So I put the negative symbol here in front. equals, now u, going back, so that's negative 4 cosine 1/4 x plus c. Very easy, right? Okay. Example number 2, we have the integral of cosine 5x dx. So again, using U substitution, let u be equal to 5x. Now solving for the derivative du over dx, that is simply 5 dx. Then recall the integral of cosine x dx based on the formula or the rules given earlier. So the integral of cosine x dx is equal to sine x plus c. Now let's rewrite the given function. So that's integral of cosine 5x, that's our u. Now since du is 5 dx, we can rewrite this part here. We can write that one as 5 dx, right? And since we put 5 here, of course, we need to put 1/5 here outside of our radical symbol. So that's equal to 1/5, the integral of cosine 5x is our u, 5 dx, that's our du. So this one is in this form, therefore that's 1/5 sine u plus c. And of course, going back, the value of u is simply 5x plus c. So again, that's very easy since you already know how to do or to perform U substitution. All you have to do now is to be familiar with the rules for integrals of trigonometric functions. For our third example, we have the integral of sine squared x cosine x dx. We can actually rewrite this function as the integral of sine x squared cosine x dx. So we can let u be sine x. And if you would recall, for differential calculus, the derivative of sine x is, if you said or if you thought of cosine x, that's correct. So that's cosine x dx. So having that, we can rewrite or we can proceed with the function that's the integral sine x, that's our u, so that's u squared cosine x dx, that's our du. If you can still remember, if you have that certain function, we can apply the power rule. So that's simply u cubed over 3. Remember, if you have this one, just simply add 1 to your exponent. Whatever your exponent is, that will be your denominator. So that's u cubed plus c. And going back, u cubed or u is sine x, right? So that's sine x cubed over 3 plus c. Or we can rewrite that one as sine cube x over 3 plus c. Okay. Let's proceed now with example number 4. That's the integral of tangent x dx. So if you would look back to the rules given earlier, the integral of tangent x dx is simply equal to the natural logarithm of secant x, natural logarithm of the absolute value of secant x plus c. Now let's try to prove this one. So using trigonometric identities, tangent x can be written as sine x over cosine x dx. So again, if you would like to ask where did we get sine x over cosine x, try to review your trigonometric identities. So having that, we can let u be cosine x. Now review the earlier we look for the derivative of sine x. The derivative of sine x is simply cosine x. Now this time, what's the derivative of cosine x? So if you can still remember, the derivative of cosine x is negative sine x dx. So let's go back here. So that's the integral of, now du is sine x dx. So we can rewrite that part as sine x dx over cosine x. Now since we put the negative sign here, we need to put another negative sign here to offset the negative symbol. So that's the integral of negative sine x dx is du, right? Over cosine x, that's our u. Now last time I already discussed about the rules for natural logarithm. So this one, the integral of du over u, I'm sorry, we need to put the negative symbol here. So going back, the integral of du over u is simply the natural logarithm of the absolute value of u plus c. Okay? And going back, that's the negative natural logarithm of the absolute value of u. U is cosine x plus c. Now distributing the negative natural logarithm, that is ln, the absolute value of 1 over cosine x plus c. And again, for trigonometric identities, 1 over cosine x is simply equal to secant x plus c. So therefore, we have proven that the integral of tangent x dx is really equal to the natural logarithm of the absolute value of secant x plus c. By the way, if you have questions, feel free to comment your questions below, or you can also send your questions in our group chat so that I will be able to entertain and answer your queries. Okay? Let's have example number 5. So example number 5 is the integral of tangent 3x dx. Earlier, we have proven that the integral of tangent x dx is equal to the natural logarithm of the absolute value of secant x plus c. Let's try to apply this given rule in example number, or for example number 5. So using U substitution, let u be equal to 3x. Of course, du over dx is 3 dx. Rewriting the given function, that's the integral of tangent 3x. And since du is 3 dx, we can rewrite dx as 3 dx But of course, we need to put 1/3 outside of our radical symbol. So that is 1/3 integral of tangent 3x is u, 3 dx is du. So that's 1/3 tangent u du or tangent x dx is equal to the natural logarithm of secant u, the absolute value of secant u plus c. And back substituting 1/3 ln, the absolute value of secant u is 3x plus c. Next we have example number 6. Example number 6 is the integral of x cotangent x squared dx. So we can let u be x squared, and the derivative of x squared with respect to dx, that is 2x dx. And to recall the rule for cotangent, the integral of cotangent x dx based on the rules given earlier is the natural logarithm of the absolute value of sine x plus c. So rewriting, we can rewrite that one as the integral of cotangent x squared. Now du is 2 dx and we only have x, so we write 2 there. But again, don't forget to put 1/2 outside of the radical symbol. So that's 1/2 the integral of cotangent x squared, that's u, 2x dx, that's our du. And applying the given rule, that's 1/2 integral of cotangent u du or cotangent x dx is the natural logarithm of the absolute value of sine u plus c. And sine u, if you go back, is simply x squared plus c. So that's example number 6. Example number 7, that's the integral of secant the square root of x dx over square root of x. Take note that we cannot cancel the square root of x because this is for that given function and this is simply square root of x. For calculus, what we usually do if we have the radical symbol, we express that one in exponential form. So if we rewrite, that's the integral of secant square root of x, we can rewrite as x to the power of 1/2. This one we can rewrite as x to the power of negative 1/2. Why negative? Because if we want to put it on the numerator, we need to look for the inverse, or if it's positive, then the sign will be negative dx. Okay, so we can let u be x to the power of 1/2. Now, the derivative of x to the power of 1/2 with respect to dx is bring down the exponent 1/2, then x. So instead of adding, because we add for integral calculus, for differential we subtract. So 1/2 minus 1, that is simply negative 1/2 dx. So now let's recall the formula or the rule. The integral of secant x dx is the natural logarithm of the absolute value of secant x plus tangent x plus c. Okay, so let's rewrite this one. That's the integral of secant x to the power of 1/2. That's our u. Du is 1/2 x to the power of negative 1/2 dx. Now since we put negative 1/2 here, we need to put 2 outside of our radical symbol, and that's equal to 2 integral of secant x to the power of 1/2, that's u. This one is du. So applying the rule, that's 2 the natural logarithm of the absolute value of secant u plus tangent u plus c. And back substituting, that secant u is x to the power of 1/2, or simply the square root of x plus tangent square root of x plus c. So I'm sorry it doesn't fit in the board anymore, but I hope the answer is clear. For example number 8, we have the integral of sine x plus cosine x over cosine x dx. Applying the rule for the integral, we can actually distribute the integral symbol. We can create here two quantities. So first, you can have the integral of sine x over cosine x dx. The second one, we can have the integral of cosine x over cosine x dx. And later, we can actually simplify this one. So, the integral of sine x over cosine x for the trigonometric identities, that is equal to tangent x dx, and this one is equal to 1, right? Cosine x over cosine x is 1. And this one we already discussed earlier. The integral of tangent x dx is equal to the natural logarithm of secant x, and the integral of dx is simply x, and do not forget plus c. Example number 9, we have the integral of secant squared 2x dx. So let's start by letting u be, can have 2x. So du is simply 2 dx. So du with respect to dx. And recall the integral of secant squared x dx is equal to tangent x plus c based on the rule earlier. So we can rewrite this one as the integral of secant squared 2x. Du is 2 dx, so we can rewrite that as 2 dx. And again, don't forget to put 1/2 outside of the radical symbol. So that's 1/2 the integral of secant squared 2x is u, that is du, Applying the rule, that's 1/2 secant squared u du is simply tangent u plus c. Therefore, we have tangent u, or u is simply 2x plus c. We are now down to our last example. Number 10, the integral of cosecant squared 8x dx. So let u be equal to 8x. Du with respect to dx is, of course, 8 dx. And recall, for the rule, the integral of cosecant squared dx is equal to negative cotangent x plus c. So rewriting the given function, we can rewrite that one as the integral of cosecant squared 8x, and since du is 8 dx, we can write this one as 8 dx, and do not forget to put 1/8 outside of the radical symbol. So that's 1/8 integral of cosecant squared 8x is u, 8 dx is du. So that's 1/8 the integral of cosecant squared u du is simply, so since the integral of cosecant squared dx is negative cotangent, so we can put the negative symbol there, cotangent u plus c, and cotangent u is 8x plus c. So that's it for integrals involving trigonometric functions. For your attendance, kindly comment your name, your course, your year level. Then for your activity, kindly send in our group chat. Kindly create your own example of solving for the integral of trigonometric functions, and show your solution on how you came up with the answer. Just send one example. Okay, so again, that's it for this discussion. Thank you so much, you guys. You take care always. Bye bye for now.